Welcome to Study Loop.
So in this problem, we are given with this reaction equation, and we have to find out for some changes how the yield of the nitric oxide at the equilibrium will change. So the first one is if we increase the concentration of the ammonia, um, whether the yield of nitric oxide at the equilibrium will increase, decrease, or will not change. So if we increase the concentration of ammonia, that means we are increasing the concentration of a reactant. That means it will increase the rate of the uh, forward reaction, and that means the yield of nitric oxide at the equilibrium will increase. Then the second one, we are asked to find out if we change the concentration of water, what will happen for the yield of nitric oxide at the equilibrium. So if we change the concentration of water, that means we are increasing the concentration of a product. That means it will react with some of the nitric oxide to form or to produce some of the reactants. That means the reverse reaction rate will increase, and that means some of the nitric oxide will be consumed. That means in that case, the nitric oxide yield will decrease. Then in part C, we have to find out if we decrease the concentration of oxygen, what will happen. So if we decrease the concentration of oxygen, that means um, some of the products, that is nitric oxide and water, will react to produce some more oxygen to neutralize the change, and this way, again, the yield of nitric oxide will decrease. Then in part D, we are asked to find out if we decrease the volume of the container, what will happen. So if we decrease the volume of the container, that means the reaction or the equilibrium will move in a way in which there is lesser number of molecules present. So if we look at the reaction balanced equation, we can see that in reactant side we have 4 plus 5 total 9 molecules, and in the product side we have 4 plus 6 total 10 molecules. So we have lesser number of molecules in the reactant side. That means if we decrease the volume, um, the reaction will go in the reverse direction, and that means some of the nitric oxide will react with some of the water to produce some ammonia and oxygen. That means in this case also the yield of nitric oxide at the equilibrium will decrease. Then in part E, we are asked to find out if we add a catalyst, whether or not it will change the yield of nitric oxide. So when we add a catalyst, what happens is it increases the reaction rate in both directions. So the role of a catalyst is to reach the equilibrium at a faster rate, and in that case, both the forward and the backward reaction rate will increase. That means adding a catalyst will not increase the yield of nitric oxide. So the answer to question E will it will be left unchanged. So the nitric oxide yield in this case will remain unchanged. And then in last one, we are asked if we increase the temperature, what will happen for the yield of nitric oxide. So from the Delage field, we can see that this is an exothermic reaction. That means heat is being produced in this reaction. So if we increase the temperature, that will favor the reverse reaction, not the forward reaction. So increasing the temperature will favor the backward reaction, and that means some of the nitric oxide will react with some water to produce some ammonia and oxygen. That means in this case, nitric oxide yield again will decrease.